All right, 9.3, I think this is. Yeah, this is 9.3a. And 9.3 is all about hyperbolas. And this first part will just be the general information. And then I'll probably make another video for the graphing. So A part will be graphing. And then when we get to the B section, that will be the actual equations, or like writing the equations. So let's just get started with some information. So a hyperbola is a set of points such that the difference of the distances from any point on the hyperbola to two fixed points remains constant. These fixed points are called the foci. So that's the definition of the foci. Like I told you before, this information isn't like the most important. It's just kind of your general information. The only difference between this and an ellipse is that now these 2 points, D1 and D2, are these two lines. It's D1 minus D2, and that remains constant for all points on the parabola. All right. So then you'll have two types of hyperbolas. I said parabolas. You'll have two types of hyperbolas, and they'll be horizontal and vertical. And I'll tell you, just looking at an equation, how to tell the difference between the two. So horizontal means that it's opening left and right. So it follows these two lines right here. And if it opens up left and right, you can know that just from looking at the equation. So if it leads with x, so if x leads, meaning that if you have like x minus 3 over, or squared over 4 plus everything else, that x is the first term, or it's in the first term. So that's what it means when I say x leads. So if x leads, then we have a horizontal hyperbola. So it'll look like this. It'll open up on the left and right. And then if we look at a vertical hyperbola, they open up on the top and on the bottom, and those are y leads. And that means that you'll have something like y minus 3 squared over 36, and then everything else. Actually, it would be minus, not plus. But you'll see when we get to that. So that's what that means. You'll notice I'll reference back to this a lot. So just make sure you've got that written down. And you know that horizontal means that x leads. Vertical means that y leads. Horizontal opens up left and right. And vertical opens up and down. So now we're going to label everything. So the center here on each of these, you'll notice, is actually not on either of these two lines or either of these two graphs. So the center is actually in between those. So the center, if we go down here to our actual like definitions, our center for a hyperbola is the midpoint of the foci, which that's just some definition stuff. So in each of these, the center would be right here. All right, so now we're going to look at our vertices. Our vertices will always be where our actual lines go through. So you see how each of these lines go through those points? Those points are the foci. So here or not the foci, I'm crazy, are the vertex. So here we have a vertex. Here we have a vertex. And a vertex is a turning point, and they are plus or minus a units away from the center. So the turning point part that it's talking about is, like if we look at the vertical hyperbola, that's where the actual graph goes to, and then it turns upward. That's where the actual graph is, or where the actual line is, for lack of a better word. All right, so now we'll look at our co-vertices. So if those are our vertices, our co-vertices actually are not on the actual line itself. The only thing that's actually on the line itself for each of these hyperbolas is the vertex. Everything else, the center's not on that line, the foci are not on that line, but the co-vertices will not be on the line, and they will be, that'd be a co-vertex, and this would be a co-vertex. Those will actually be plus or minus b units away from the center. So if we were to start at the center, which I'll get rid of some of this. If we were to start at the center here and count up and down, that would get us to our covertices. So those are our covertices. And then you'll see these little, I'll look at the vertical one. You'll see this line here. These two dotted lines, those are asymptotes. So those are our asymptotes, and they help us guide our graph, similar to how we did when we were doing rational functions. And we graphed them just by, they were guiding, those asymptotes were guiding our path. It's similar to how these work, and I'll show you a neat way that we can actually graph these, or a neat way to find your asymptotes without actually having to do any calculations. So the asymptote here, like it says, it's these diagonal lines that are the guide for our curves. And like I said, I'll show you a neat little way to actually graph those. So then the foci is plus or minus c units away from the center still. And in our actual graph, our foci would be these 2 points right here, which I'm not sure what just happened. Here are 2 points right here. And they're actually outside. So with a circle and then, with an ellipse, they were on the inside of the ellipse. Now they're on the outside of these two hyperbolas that we have. And then the only thing that changes here is the formula. So the formula for C is now C squared equal to A squared plus B squared. And remember, on ellipse, I told you it was not the Pythagorean theorem. On this time, or on these hyperbolas, this is the Pythagorean theorem. So that's a good way you could remember each of these. So the only thing that we're missing here is I'll show you, once we get to the graphs, I'll show you the little trick to actually find your asymptotes. I'm not going to show you now, so I don't want to confuse you. But I'll reference back to this to probably show you in a little bit. But we're going to get just the standard form written down, and then we'll get the equations of an asymptote. But for that actual asymptote, like I said, I'm going to give you a little trick to find that. So you may not have to do these calculations until the end. But be sure to get these standard forms written down. So the standard form for a horizontal, because this is sectioned off very similar to how our ellipses was, this is horizontal, and then this side is vertical. So when we do each of these sides, that's what we're looking at. All right. So we've got x minus h squared over a squared, just like with an ellipse, except now it's minus y minus k squared over b squared, and everything's equal to 1. So the only difference between this equation and an ellipse was this minus sign here changed. It was a plus sign, now it's a minus sign. Now when we look at, when we look deeper into this, you'll see what I was saying about x leading, because this would be a horizontal hyperbola because that x is in the first term. This is a term, and this is a term. The x is leading. It's in the first term. So we would know just based upon that this is a horizontal hyperbola. Now watch what happens when we do the vertical. Instead of it being x minus h, now it's y minus k squared over a squared minus x minus h squared over b squared. And everything's still equal to 1. So notice here, this would be a vertical hyperbola, and y is leading. Y is in that first term, so y is leading. So that's an easy way to really know the difference between the two. That tells you a lot of information. But those are your two general setups. It's really just an ellipse setup, except you have minus signs here, and then you also may have x leading, and in that case, it's a horizontal hyperbola. And if y is leading, it's a vertical hyperbola. Then the equations for an asymptote. And this part probably will just be you plugging in these values. Once you find a and b, you'll be able to plug them into this. So y is equal to plus or minus, which means you'll have two separate equations, because if you notice here, there's two separate asymptotes. So you need an asymptote or equation for that asymptote and an equation for that asymptote. And this is how you get it. You say for a horizontal asymptote, you say y is equal to plus or minus a over b, or b over a, times x minus h plus k. And then for a vertical asymptote, we just switch a and b. So now it's y is equal to plus or minus a over b times x minus h plus k. And for that part, I'll show you it's really just plugging in what you found into this equation of an asymptote. And for this part, I may not even make you reduce it all the way, just because some people will teach you to do this part in order to graph your asymptotes, but I'm not going to do that. We have a little cheat code we're going to use. So in the next video, I'll do graphing hyperbolas, and hopefully that won't be too long, but that is it for this general information video.